Hello, welcome back to Learn with Biju. In today's Python programming session, we will be discussing Python math functions. This module we will be covering math module, constants provided by the math module, numeric functions, logarithmic and power functions, trigonometric and angular functions, and finally the special functions. If you have not seen the previous sessions, links are added in the description. Please watch before proceeding. Let's begin.
So welcome to Python math module. Sometimes when working with some kind of financial or scientific projects, it becomes necessary to implement mathematical calculations in the project. If you have worked on or if you have learned some other languages like C, C++, Pascal, Delphi, or any language that for that matter, you might have learned about math functions and the libraries, the header modules, header files, and so on. Python provides the math module. Which module? Math module to deal with such calculations. Math module provides functions to deal with both basic operations such as additions, subtraction, multiplication, division, and advanced operations like trigonometric, logarithmic, exponential functions. So in this session, we will discuss about the math module from basics to advanced using some examples. Let's start with constants. What is the benefit of a constant? Having a constant saves the time of writing the value of each constant every time we want to use it, and that too with a great precision. Constants provided in the math module are Euler's number, pi, tau, infinity, not a number, that is nan. So let's see the constants in detail. As I mentioned, we will try to have some examples to understand the constants thoroughly. I'm back to my Jupyter notebook. I'm going to show you how to import a library in Python. So we are using import command with the module name. I am going to do import math function. So just run the command, and first thing we are going to see the Euler's number. So how are you using the constants? So math.e, math.e. Okay, let's try to run this command. So what I'm going to do, I'm going to print the value of Euler E. See, that is 2.7182818284599045. We got the output value, right? So as I mentioned beginning, constants are going to save our time of writing the value of each constant every time. So instead of writing this 2.7182818284599045 every time, we just going to use the constants provided by the math function math.e, right? So for example, I want to make a calculation. How is that? Print 10 into math e. Okay, so it is going to give you 27.18281828459045. I don't need to write every time this big number, right? It is giving you a high precision number. I can just simply use the constants. That is where the constants are very useful to us. So let's see what is the next constant. Next constant we are going to see is pi. Okay, pi. What is the syntax? It is the math.pi. So you all must be familiar with pi, right? The pi is depicted as either 22 by 7 or 3.14. Pi is depicted as either 22 by 7 or 3.14. Okay, so the syntax of pi is math.pi. Okay, let's try to execute a command, print math.pi. So you're going to get 3.1415926535897993. Okay, so if you write a function to print pi, you can write like this. First of all, you need to import the math library, import math, then print pi. Cool. That is the math function. That is the pi. So using the pi, we can calculate the area of a circle. Okay. So where radius of a circle is 4, value of pi is 3.1415926535897993. Then area is pi into r square, right? So let's try to print the function calculating the area using constant pi. So look at this program. First of all, I am importing math module. Then I am declaring a variable r, that is radius, and giving the value 4. Then we are getting the value of pi. Then area of circle is going to be printed. Let's try to execute this command. It is 50.26548245743669. So do you understand how you are applying the value of a constant in a program? Okay, and how to include a math module in a program? It's very simple. We need to import the library, declare variables, use the constant, and apply the formula. Got it? Then the next constant we have is tau. Okay, so how are you going to use this formula and what is it meaning? It is defined as the ratio of the circumference to the radius of a circle. The math.tau constants returns the value 6.28318530717956. Let's try to apply the syntax. Okay, so we have math dot, let's print this. So that's it. We have 6.28318530717956. So what is this tau? It is it is defined as the ratio of the circumference to the radius of a circle, and and this is the constant value. Okay, let's see an example of tau. So I am just including the math library and I'm just printing it, which already we have done. Okay, next we are going to see the constant infinity. So what is infinity? Infinity basically means something which is never ending or boundless from both directions. That is negative and positive. Infinity cannot be depicted by a number. The math.inf, constant returns of positive infinity. For negative infinity, use minus math.inf. Okay. For positive infinity, use math.inf. For negative infinity, use minus math.inf. Okay. Let's try to see the value of infinity. Okay. So I am importing the math function. Then I am going to print the positive infinity, print math.inf. Then I'm going to print the negative infinity, print minus math.inf. Let me run this. So it is showing the output as inf and negative inf. As I already mentioned, the infinity value cannot be expressed by a number. Okay, write a program to compare the values of infinity with the maximum floating point value. How I am doing? I am actually comparing whether math.infinity greater than the maximum of the floating point value and the negative floating value. So let me print that. So here it shows that math.inf is greater than the maximum of the positive floating value, and minus math.inf is less than the minimum of the negative floating value. Both are true. That means both time the infinity is greater, infinity is lesser. Okay. So that is the infinite constants in Python. And what is the last one? It is nothing but nan, not a number. What I meaning? Math.nan constant returns a floating point nan, not a number value. This value is not a legal number. The nan constant is equivalent to float nan. So let me try to show them with an example. What is the value of nan? Here I am actually importing the math library. Then I am going to print the value of math.nan. So it is just printing nan. Next topic we are going to see in detail is numeric functions. We will start with finding the ceiling and floor value. Ceil value means the smallest integral value greater than the number, and the floor value means the greatest integral value smaller than the number. This can be easily calculated using ceil and floor method respectively. We have a method called ceil, and we have method called floor. These are the two functions to ceil and floor a number. Okay, let's try to make an example of this. I'm going to show you a code to demonstrate the working of ceil and floor. So first of all, what we need to do? We need to import the math library, and we have a variable called a, and we give the value 2.3. 2.3. Okay. So what is the ceil of 2.3? So what will happen? It will show you the what is ceil of the middle. The value means the smallest integral value greater than the number. The smallest integral value greater than 2.3. So what should be that? And if you are flooring 2.3, what you are getting? The greatest integral value smaller than the number. smaller than the number. So the smallest integral value greater than the number is ceil, and the greatest integral value smaller than the number is floor. So let me try to execute and see what is the output of ceil and floor. The ceil of 2.3 is 3 and the floor of 2.3 is 2. What do you mean by this? So 3 is the smallest integral value greater than 2.3 and 2 is the greatest integral value smaller than 2.3. Are you able to follow this? Next we are going to see the factorial of a number. Using the factorial function, using the factorial function, we can find the factorial of a number in a single line of code. An error message is displayed if the number is not integral. I'm going to demonstrate the code to show you the working of a factorial. First of all, you need to import the math function. Then we need to declare an integral value. Here I have a equal to 5. Then I am going to see the factorial of 5 is how? Math.factorial of 5. Here you are getting 120. So what is the factorial? Factorial is the product of an integer and all the integers below it. Factorial is the product of an integer and all the integers below it. So here how can I explain, how do you know if 120 is correct or not? So what we can do is we can say print 1 into 2 into 3 into 4 into 5. This is the factorial. This is the factorial. So 120, I am getting 120. So instead of calculating the product of 5 and all the integers below 5, I can just simply use math.factorial. Then I'm going to get the value 120. So this both printing 1 into 2 into 3 into 4 into 5 is equal to math.factorial of 5. Understood? Next one we are going to see is a function called GCD. GCD function is used to find the greatest common divisor of two numbers passed as the argument. What is the GCD? Greatest common divisor of two numbers passed as an argument. Okay, let's try to see that in an example. Again, this is a code to demonstrate the working of GCD. First of all, I am importing the math module. Then I have two numbers, a equal to 15 and b equal to 5. And if I want to see the greatest common divisor of 15 and 5, a and b, let me see what it is. It is 5. Is it right? 5 can be divided by 5. 15 can be divided by 5. And that is the greatest common divisor. So if you want to understand the greatest common divisor of two numbers, you can use the function from math module GCD. How are we using this? Math.gcd and number 1 and number 2. Okay, so the result is 5. The next numeric function we are going to see how to find the absolute value of a number. For that we have a math function fabs. What is the syntax? Math.fabs. Find Let me demonstrate a program that finds the absolute value. So as always we do, let's import the math module. Then we have a variable a equal to minus 10. So we need to return the absolute value of minus 10 and using the math.fabs method. So it is going to give you 10. The absolute value of minus 10 is 10. So hope we understood the various numeric math functions. What are those? Ceil, floor, factorial, then we have GCD, then we have fabs. With that, the numeric functions are over. Next, we will check the logarithmic and power functions. Our next topic is logarithmic and power functions. Power functions can be expressed as x raised to n, where n is the power of x, where the logarithmic functions are considered as the inverse of exponential functions. So finding the power of exponential. So we have a method exp. The exp method is used to calculate the power of e, that is exponential of y. We can say exponential of y. So what is the function exp? Math.exp. So the exponential function exp of x calculates the value of e to the power of x, where e is the base of the natural logarithm 2.7182818288. Okay, what is that? The exponential function exp calculates the value of e to the power of x, where e is the base of the natural logarithm 2.71828188. It is the code to demonstrate the working of exp. First of all, we'll import math. Then we have different variables like int, negative int, float. So first we will see what is the exponential of 4 and minus 3 and 0. Let's me run this program. So we got the exponential of 4 as 54.5981500331442236, and we have the exponential of minus 3 as 0.049787068368367863944, and we have the exponential of 0, that is 1. So please remember, the exponential function exp of x calculates the value of e to the power of x, where e is the base of the natural logarithm 2.71828188. The next math function we are going to see is power, POW. The syntax is math.pow. So what is a power? The power function computes the nth power of a number. This function first converts its argument into float and then computes the power. Let's have an example to demonstrate. Here is a Python code to demonstrate POW. We are going to see the fourth power of 3, that is 81, right? So let's execute and see. And how do you confirm this is right? You can simply print 3 into 3 into 3 into 3. This is becomes 81, right? So the fourth power of 3 is 81. So if I want to see a fourth power of 5 is, what's the power of that? It's 625. Okay, so we have function power. Then we have some functions for finding the logarithm. The log function returns the logarithmic value of a with base b. If base is not mentioned, the computed value is of the natural log. Then we have log 2 function. It computes the value of log with base 2. This value is more accurate than the value of the function discussed above. Then we have log 10 of a. This function computes the value of log a with a base 10. This value is more accurate than the value of all log and log 2. Here we have a program. First of all, we are importing the math function. Then we are returning the log of 2, 3. Then we are returning the log 2 of 16. And because it is the base 2, then we have the log 10 of 10,000. So let's try to run this program. So that we have the value of log 2. We have the value of log 2 with base 3 is 0.6309297535714574, and we have the log 2 of 16 4. Then we have the value of log 10 of 10,000 is 4. So these are the different logarithmic values. We have the next function, square root. What is the square root doing? The function is sqrt. The syntax is math.sqrt. This function returns the square root of a number. This function returns the square root of a number. So let's have an example. So first of all, we are importing the math module. Then we are printing the square root of 0. We are printing the square root of 4. We are printing the square root of 3.5. So the square root of 0 is 0. Square root of 4 is 2. Square root of 3.5 is 1.8708286933869707. So this is the square root. Okay, so we have seen the logarithmic and power functions includes exp, then we have power, then we have log, then we have square root. Okay, so these are the logarithmic and power functions. The next topic we are going to cover is trigonometric and angular functions. You all must know about trigonometric and how it may become difficult to find the values of sine and cosine values of any angle. Math module provides built-in functions to find such values and even to change the values between degrees and radians. So what are the trigonometric functions? We have sine, we have cosine, then we have tangent. And we have functions like sin, then we have cos, then we have tan. These functions return the sine, cosine, and tangent of value passed as the argument. The value passed in this function should be in radians. Remember, this argument should be in radians. Let's see an example. So we are going to demonstrate sine, cos and tan. So first of all, we imported math module. Then we have declared a variable math dot pi divided by 6, and the value of a is math dot pi divided by 6. So we are calculating the sine of a, the cosine of a, and the tangent of a. Okay, let's see what is the result. What is the output? The value of sine of pi divided by 6 is 0.49999. It's a big number, right? Then we have a cosine of a and we have tangent of a. Now let's see how can I convert from degrees to radians and vice versa. So we have function called degrees. This function is used to convert argument value from radians to degree. Then we have another function radians. This function is used to convert argument value from degrees to radians. So we have degrees and we have radians, and the degrees function is used to convert argument from radians to degree, and radians function is used to convert argument value from degrees to radian. So probably you will be interested to see an example for this. Okay, let's see a small example. Let's have a new command. First of all, I am just importing the math module. Then I am again getting math dot pi divided by 6, that is a. Then we have a b variable with value 30. So returning the converted value from radians to degree. So the converted value from radians to degree is, then first we are passing the value of a, which is radians, and again it is converted to degree. Then we have a variable b which is having the value of degree, that's 30. So we want to get the radians equivalent to 30. So when you run this program, we are using two functions. One is math dot degrees, and we are using math dot radians. So let's run this example and see. So we are getting the converted value from radians to degree is 29.999, and converted value from degrees to radian is 0.5235987755982988. Okay, so we understood the use of degrees and radians. Then we have few special functions, maybe finding the gamma value. So we have a function called gamma, and the syntax is math dot gamma. This function is used to return the gamma value of the argument. So let's have an example. Here we have imported the math module. Then we have a gamma variable 6. Then we are printing the gamma value of the given argument, which is 6. So let's see what is that. The gamma value of the given argument is 120. The gamma value of 6 is 120. Then we have one more function. Special function is like if you want to check the value, the value of a number is infinity or none. So we have is inf. That is a function is inf. that will be checking the whether the value is infinity or not. Is infinity function will check whether the value is infinity or not. For that example, I can have an example. So we have something, we are going to check the value of pi is that infinity, or we are also checking math.e. Let's try to run this, whether if you are seeing the float of infinity is infinity. Right? It should be right? The float of infinity should be infinity, right? But pi value should not be infinity and e value should not be infinity. Yeah, you see the first two are not infinite, but the last one is infinite, right? Okay, so the function we have, what is the function name? It's a inf is the function which is checking whether the value is a infinite value. Then we have function to check whether it is a non-number. It is nan, not a number. This function is returns the true if the number is nan, that is not a number, else return false. So do we need an example for that? Okay. So we are importing the math module. Then we are checking whether pi is not a number or e is not a number, or we are just checking if not a number itself is not a number. Yeah, again, this is also the first two numbers are not are false because they are numbers, and the last one nan is not a number, so it is returning true. Yes, before closing, let's have a quick recap. In this session, we have seen the Python functions, and we understood that all the functions in Python is in the math module, and we can easily integrate the math module in your program. And we have so many math functions which is going to support you, and we have the constants also, and some of the functions like ceil, floor, then we have gcd, then we have the log functions, and we have the power functions, square root functions. So all these are very handy when you need to have some calculations in your projects. So please refer this video whenever we have some doubts, and hope this was really useful to you.
Thank you for watching today's session. I hope this is really helping you. Please share your feedback and suggestions in the comment box. We will meet with a new topic next week. Thank you.